Hey everyone! Welcome back to Math for Kids. Today we're diving into an exciting topic: angles and geometric figures. Let's explore how angles help shape the world around us. First, let's understand what an angle is. An angle is formed when two rays meet at a common point, called the vertex. Angles are measured in degrees using a tool called a protractor. Now let's look at the different types of angles. An acute angle is greater than 0 degrees but less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees but less than 180 degrees. A straight angle measures exactly 180 degrees. It looks like a straight line. To find an unknown angle in a figure, we first need to understand the properties of angles. In this video, we'll start with the first property: angles on a straight line. The sum of angles on a straight line is always 180 degrees. Let's look at an example. Here we have two angles, angle AOC and angle COB. Together they form a straight line, so their sum is 180 degrees. Now let's apply this to a real problem. We're given two angles, 50 degrees and 75 degrees, and we're asked to find the unknown angle x. According to the angle on a line rule, x plus 50 degrees plus 75 degrees equals 180 degrees. To find the value of x, we subtract 180 to 50 degrees minus 75 degrees equals 55 degrees. So the value of angle x is 55 degrees. Simple, right? Let's keep practicing. Now let's move on to another important property: angles at a point. The sum of all angles around a point is always 360 degrees. Take a look at this figure. When we add angle AOB, angle AOC, and angle BOC, their total is 360 degrees. Let's see how we use this rule in a real problem. In this example, we're asked to find the value of angle x. Based on the rule for angles at a point, we know that x plus 45 degrees plus 75 degrees plus 160 degrees equals 360 degrees. To find x, we subtract the known angles from 360. 360 to 45 degrees minus 75 to 160 degrees equals 80 degrees. So the value of angle x is 80 degrees. And that's how you apply the rule of angles at a point. Next, let's look at the property of vertically opposite angles. When two lines intersect, the angles opposite each other are always equal. These are called vertically opposite angles. In this figure, we have two lines, AB and CD, intersecting at point O. This creates four angles. According to the rule, angle AOD equals angle BOC, and angle AOC equals angle DOB. Now let's apply this rule to a real problem. In this example, we're asked to find the values of angle B and angle C. Since the two lines intersect, we can use the vertically opposite angles rule. We are given that the opposite angle is 120 degrees and 60 degrees, so angle B equals 120 degrees. Angle C equals 60 degrees. And that's how vertically opposite angles help us solve for unknowns. Now let's move on to the property of triangles. The sum of the interior angles in any triangle is always 180 degrees. In this figure, you can see that the sum of angles A, B, and C equals 180 degrees. Let's apply this rule to a real problem. In this example, we're asked to find the value of angle A. According to the triangle angle sum rule, we can calculate angle A like this: 180 to 80 degrees minus 40 degrees equals 60 degrees. So the value of angle is 60 degrees. That's how we use this property to solve for unknown angles in a triangle. Now, let's look at the property of an equilateral triangle. An equilateral triangle has three equal sides and three equal angles. Since all the angles are the same and their total is 180 degrees, each angle in an equilateral triangle is 60 degrees. Let's apply this rule to a real problem. In this example, we need to find the value of angle y. We can see that all three angles in the triangle are labeled y. That tells us it's an equilateral triangle. So by the rule, the value of angle y is 60 degrees. Easy and straightforward. Now, let's look at the property of an isosceles triangle. An isosceles triangle has two equal sides and two equal angles. These are called the base angles. In the figure shown, sides AB and AC are equal, which means the triangle is isosceles. So the angles at B and C are also equal. Let's apply this rule to a real problem. In this example, we need to find the value of angle x. Since the triangle has two equal sides, it's an isosceles triangle. We are given that the angle at the top is 30 degrees. Using the angle sum rule for triangles, 180 to 30 degrees equals 150 degrees. Now divide the remaining 150 degrees equally between the two base angles. 150 degrees divided by 2 equals 75 degrees. So the value of angle x is 75 degrees. And that's how we solve problems using the properties of an isosceles triangle. Now let's move on to the property of a square. A square has 4 equal sides and 4 equal right angles, with each angle measuring 90 degrees. As you can see in the figure, all sides are the same length, and each corner forms a perfect right angle. Simple, strong, and symmetrical, that's the square. Now let's move on to the property of a rectangle. A rectangle has 4 right angles, and its opposite sides are equal and parallel. As you can see in the figure, each angle is 90 degrees, and both pairs of opposite sides are exactly the same length. That's what makes a rectangle a strong and balanced shape. Now let's move on to the properties of a parallelogram. A parallelogram has opposite sides that are both parallel and equal in length. It also has opposite angles that are equal. Another important property is that any two angles next to each other are supplementary, which means they add up to 180 degrees. As you can see in the figure, these properties help define the shape of a parallelogram. Now let's apply this rule to a real problem. In this example, we need to find the values of angle ADC and angle BAD. Since opposite angles in a parallelogram are equal, and we're given that angle ABC is 120 degrees, that means angle ADC is also 120 degrees. To find angle BAD, we use the rule that adjacent angles add up to 180 degrees. 180 to 120 degrees equals 60 degrees. So angle BAD is 60 degrees. And that's how we use angle properties to solve problems in a parallelogram. Now let's move on to the properties of a rhombus. A rhombus has 4 equal sides, and its opposite sides are parallel. It also has opposite angles that are equal. Another important property is that any two angles next to each other are supplementary, which means they add up to 180 degrees. As you can see in the figure, all sides are the same length, and the shape maintains its symmetry through equal angles and parallel sides. Now let's use these properties to solve a real problem. In the given figure, we need to find the values of some unknown angles. Since the shape is a rhombus, we know that opposite angles are equal. So, if angle ABC is 110 degrees, then angle ADC is also 110 degrees. To find angle BAD, we use the rule that adjacent angles in a rhombus are supplementary. 180 to 110 degrees equals 70 degrees. So angle BAD is 70 degrees. That's how we use the angle properties of a rhombus to solve for unknown angles. Now let's look at the properties of a trapezium. A trapezium has one pair of opposite sides that are parallel. Another important property is that the adjacent angles between the parallel sides add up to 180 degrees. As shown in the figure, this relationship helps us solve for unknown angles. Let's apply this rule to a real problem. In this example, we need to find the value of angle CDE. Since the figure is a trapezium, and sides CF and DE are parallel, we know that the adjacent angles between them are supplementary. So, to find angle CDE, we subtract the given angle from 180 degrees. 180 to 60 degrees equals 120 degrees. Therefore, angle CDE is 120 degrees. And that's how we use the angle property of a trapezium to find unknown angles. And that brings us to the end of our lesson on angle and shape properties. Today we explored the angle rules and special features of different 2D shapes, including triangles, squares, rectangles, parallelograms, rhombuses, and trapeziums. We learned how to use angle sum rules, apply properties like equal sides and opposite angles, and solve real problems using these rules. Understanding these properties helps us solve geometry problems more easily and confidently. Keep practicing, and you'll become a pro at identifying shapes and finding missing angles. Thanks for watching, and don't forget to like, share, and subscribe for more math learning videos. See you in the next one.